Welcome! I'm your host Bob, and this is the introductory video for the Cold-Fire Reactor project. It is plasma, but not as you know it. This project was inspired by a YouTube video I watched called Cold-Fire You Can Touch DIY Plasma Torch by the Thought Emporium. So what does this reactor do? Well, basically it reverses combustion. It converts carbon dioxide and water into a hydrocarbon and oxygen. The goal of this reactor is to produce methane as a hydrocarbon. What is great about this reactor is it theoretically does it at very high efficiencies, at 98%. So why do I want to build this reactor? I want to develop a technology to produce methane on a large scale. Methane is an important resource in the Australian economy, as it is one of Australia's largest exported goods. Also, a technology like this can be very crucial in the space industry, as methane is a popular fuel source. But most importantly, I want to develop this reactor to fix the duct curve problem. The duct curve problem arises when solar production increases in the grid. The additional solar production doesn't reduce power demands equally throughout the day, however, but instead the demand curve appears more like a duck's back, as shown in the dark graph on the right. There are two solutions to this problem without decreasing solar production. The first of which is to use liquefied natural gas power plants that run on fossil fuels, and secondly is to produce a large-scale storage of battery energy. The reactor I aim to develop will be a mix of both solutions, as it will be able to store large amounts of energy in methane to be combusted for energy at a different time in the day for a net zero carbon emission. So how will I develop this reactor? I plan to develop this reactor in 3 phases. The first uses energy from the grid as I learn more about the technology I am using. The second phase is from a small solar array to supply the energy. And the third will be a large-scale design powered by large-scale renewable energies. Unfortunately, however, these holidays I don't expect I'll be moving on from phase 1 due to the lack of time. But what am I actually doing? What is the science behind it? So the reactor uses cold plasma, which is a state of matter similar to what the sun is made out of. However, unlike the plasma in the sun, cold plasma doesn't waste its energy by heating up the nucleus of the atom, but instead most of the energy is exclusively given to the electrons, producing high energy electrons. Due to the nucleus being at a different temperature than the electrons, the atom is very unstable as a plasma, but still very safe. The goal is to turn argon gas into a cold plasma, as it ionizes easily and safely. The fast-flowing electrons from the plasma will be used to break carbon dioxide bonds and water molecule bonds. This will create the elements needed to form methane spontaneously as a product, and oxygen gas as a side product. To create the plasma in the first place, however, the right voltage is needed to be put across the argon gas to create the arc. For that I need the right hardware. The hardware I have and the hardware I need. The hardware I have: the glass capillary tubes to seal in the gas, a ZVS driver and a flyback transformer to create stable arcs, some wire and solder, and a metal box I can put it all in. And these are some of the hardware items I need: an argon tank, carbon dioxide tank, and some gas tubing. So what's next? Well, more science is sure to come your way. But after this, I basically need to build the reactor. And for that, I hope to see you next time and hopefully have fun. See ya.